Okay, here is video 2 because I only had 2 hands. I accidentally turned off the video, so this is the second part. But I did get my slice of snow cake from the density cutters into the Ziploc bag. Excellent. I don't really need to zip it up, that's not that important. But I do need to clip the scale onto this. So I'm going to do that now. I've done that. If you remember, the bag weighed 5 grams. Now I'm going to weigh this. And as I look up here, I'm finding, if you read this like I am, every line is 5, and every longer line is 10. So you have 50, 55, 60, 65, 70, 75, 80, 85 grams is what this is pretty much sitting at, which is what I just found a minute ago. So 85 grams minus the 5 grams that the bag was. So that means our density cutter, this 250 cubic centimeter slice of snow cake, okay, captured 80 grams of water. Now, if it was, just so you know again how cool the metric system is, if this was pure water, like if that snow was 100% water, no air at all, then the weight of this would have been 250 grams without the bag. And that's how that would have worked. Remember, the cubic centimeters, 250 here would have been 250 on here. You could never get that when you're measuring inches and pounds or ounces. Our system's all wackadoodle in that sort of way. So anyway, we have that. So I'm going to move over here for a little bit of math to show you how this thing works. And I'm just going to do it on paper. Could do it on a whiteboard, but I think this might actually be easier. So, show you how easy this is, my friends. So number 1, we measure the depth. So we want to write that down. And the depth of the snow was 7 point, was it 7.5 or was it 6.5? Shoot. I don't remember. And luckily, I'm right here. So I'm going to go measure it again so that I get it right, don't get it wrong. And it's one of the reasons why you want to write this stuff down when you're doing it, because you can't remember perfectly. So I'm going to go back out to the same location, walk out here, and drop the ruler one more time. And it looks like it was 6.5. But as I'm looking at it, yeah, I'm going to go with 6.5, even though it's just a little more than that. I'm not being the total accurate scientist. I am being the... Oh, be quiet, computer. Okay. So, we're going with 6.5 inches of depth. 6.5 inches. All right? Now the density, the way we figure that out is we put down 80 grams, and so it's 80 grams divided by 250 to figure out what our decimal density is, which it'll be both a decimal and a percentage. We can play both ways. So obviously, here is where our decimal goes. At least this is the way I do the math, so if you do it different, understand. So I'm going to add a 0 there. So 250 goes into 800 3 times. So already I know that our snow density is in the 30% area. So I multiply that, and that's 750. And then I bring that down, drop another 0 down to 500, and 250 goes into 500 how many times? 2 times. And so the answer is the density is 32%. That means 32%, or 0.32, okay, decimal-wise, of the 6.5 inches is pure water. So we're going to figure out how much that is exactly. So I have, again, 6.5. I'm going to do this now, 6.5 inches of water times 0.32. And you'll get to see me do how I do math. This is 5, 1, 19, boom. I'm making a mess here. 0, 0.802. And I have 3 different decimal positions noted there. So my answer is just over 2 inches of snow water. So again, if I was listing all of this, it would be density, depth 6.5 inches, density is 0.32 or 32%, and snow water, as we see here, and I'm not even going to mess with this really, I'm just going to say it's 2 inches. We could get into the decimals because actually every drop of water and every ounce or gram matters to California when it comes to the Sierra snowpack that we have up here in the Feather River region. So actually all of these, everything would matter, but I'm rounding it up for our own ease. So remember, if somebody called up to me in my office and said, oh, wow, that was a great storm. How much did you actually get on the ground at your office? And I'd say, I had 6.5 inches of snow. And they're like, oh, that's not that much, but it's better than nothing. What was your density? And I would have been able to say that I used really cool scientific tools to determine the density of the snow was 0.32 or 32%, which is very accurate. For this time of year, we often have 30, even to 40% of density in the snow. And then they ultimately want to know how much snow water is sitting around my office in Quincy, California, and I could tell them 2 inches. Now, 2 inches of snow is not that much in a cup, 2 inches of snow. But if you multiply all of the land around Quincy or other areas in this elevation that would have about the same amount of snow, it would equal a ton of water. And of course, we don't measure water by tons, but it would be gallons, it would be acre feet, and we would all know a lot more. So anyway, this is me taking you through the density, the snow sampling process using our density cutter from SnowSchool and all of the other tools that we need to measure depth and density and then figure out what the snow water is. And they lived happily ever after. So go on out there at your school with your teacher, and I want you to measure some snowpack and get good at it so that you can be the snow scientist that you were born to be. All right, take good care and pray for snow. See ya. Bye.